Good morning, everybody. I'm Simon Harrison. I have a group strategy role in Mott MacDonald, but my career interest and background is energy. I chair the energy policy panel at the IET, and I'm going to give you, and you can see the relative scale there of electricity compared to the other energy vectors. It's actually quite small, and that's there to give you a feel for size in terms of the revolution that has to take place electrifying transport and electrifying heating. There's something working for us in that the end-use efficiency of an electric vehicle is over 80%. The end-use efficiency of a petrol vehicle is less than 30%. So when you get to the vehicle, you get quite a large win at that point. So do bear it in mind. But you can see that plugging in all our vehicles and electrifying a lot of our heating is a very large change indeed for the electricity system. And that, combined with the other factors that Ross was talking about, means that what we have to do to the electricity system is, I think, the largest change since the 19th century. So this is not a little thing, it's an enormous thing. Here's an electricity system. Again, don't worry about the detail. Up the top, you've got big power stations, big transmission, the old-style system. You do have to worry for transport about whether there's enough generation. You've got to worry about that, and you might make some big generation decisions, nuclear, offshore wind, say. You might distribute it at the bottom of the diagram, local solar, local wind, and so on. But that's only half the story. The other half of the story is the network story. You have to be able to get the power to the point at which somebody wants to charge an electric vehicle. And the basics here are quite interesting. Electric vehicle charging at domestic level is moving towards 7 kilowatt chargers. The average demand of a domestic property in the UK is 1.5 kilowatts. Okay, so the charging of an electric vehicle is big compared to other uses of electricity at the domestic level. Just hold those thoughts as I go through the presentation. So what matters for the energy system? Well, there's a list. Some of it's pretty obvious. Total energy, it's got to balance. There's got to be enough capacity to meet peak demand. That's potentially a large issue. Emerging is a new issue for electricity and energy, which is ability to meet peak supply. There are times now where renewable generation is so large that the electricity system finds it difficult to cope with, and that is going to increase. We have to, in the energy system as a whole, and especially the electricity system, to balance supply and demand. You can put storage on the system to help, but broadly speaking, minute by minute, supply and demand has to equate. We have to change now, as Ross was saying, to deal with consumers who not just consume energy, but generate it, store it, use it for their electric vehicle, maybe use their electric vehicle to supply themselves or other people. It's a very, very big change for how the thing has to operate. And to be efficient in decarbonisation, we need to start integrating across all the energy vectors. So I've listed them in the slide. At the moment, we tend to think about electricity, gas, liquid fuels in isolation. They're becoming integrated. So we have to start thinking much more about a total energy system. And last but by no means least, society is in the midst of a digital transformation, in case you hadn't noticed. That's affecting energy as well. Data is becoming as important as physical flows on the system. So there are real questions being asked as to whether data now is more valuable than all the physical assets in the electricity system, or will be. And I think maybe some of those questions are being asked in the transport world as well. So what does this all start to look like? Well, National Grid publishes future energy scenarios which are based on the road to zero. So it's all tied together in that sense. There are a range of possibilities, and the headlines actually are not that frightening. So by 2050, maybe 30% more electricity will be needed and 11% more generating capacity because of electric vehicles. But sitting behind those relatively benign assumptions, numbers, are some really tricky assumptions. One assumption is that the network has become smart throughout, and that everything is data-driven, all charging is smart, that consumers are bought into a smart charging world, we have a very fragmented electricity industry, energy industry. It's less like the transport industry, I think. There are hundreds of players in the value chains, and at the moment there is very little coordination between any of them. For this to work, everything has to coordinate, and the role of regulation in finding entirely new solutions to this is essential and completely absent at the moment. What about hydrogen? We haven't talked about hydrogen this morning, really. And the predictions are, I think, that hydrogen is likely to play a significant role for long-haul transportation. And maybe to some degree, the jury is still out on the balance between electricity and hydrogen for personal transportation. And certainly in the wider energy space, the role of hydrogen in things like heating is potentially very significant and yet to be determined. So if you look at National Grid's predictions, they're talking about 30 terawatt hours of hydrogen for transport by 2050. That's about 10% of today's electricity use. It's quite big. And it's a vast increase in hydrogen usage from today. So where's this hydrogen going to come from? That first bullet is a bit mangled. I do apologize. The first bullet essentially says that we burn natural gas to get hydrogen and we store the carbon dioxide that's produced. The second is about electrolyzing spare energy from renewables. But to do that, it all sounds quite simple. It's all doable, but we need whole new industries, and we need policy coordination that drives those outcomes so that investment looks sensible. Moving now from the big picture of supply and demand to what happens at your house. As I've said before, a 7 kilowatt charger is a big multiple of average domestic demand, and that seems to be where the car industry is going. If you connect more than a few of those on a local feeder at the same time today, it's very simple. You'll just blow the fuse at the local substation and you'll have to ring up the network company to come out and replace it. So this cannot happen in an unrestricted way when this happens at scale. And I'm sure you know better than I do about how deployment of EVs tends to cluster, we think, so that neighborhoods will see one person with an EV and other people will go and buy one. So potentially deployment will cluster. So there are quite significant challenges ahead in the distribution system. Now, if you make that network smart and you coordinate charging and you use vehicle-to-grid capacity, so you use your car as generator, you can actually get a lot of mileage out of the existing cable in the ground to allow you to more EVs to deploy. However, there are limits to that, and you will get to a point where you need to make very large-scale investments in the physical networks in streets. We don't yet know enough about consumer behavior in this regard. There have been some very interesting trials, one called My Electric Avenue, for example, but they were based on 3.5 kilowatt charging, so their conclusions are perhaps less pointed than they were initially. There are trials now starting with higher charging rates, but lots to still solve and understand there. On the hydrogen side, potentially you could repurpose natural gas infrastructure for hydrogen. You can do some blending, but the future direction is really quite unclear in that regard. Maybe you can make hydrogen locally, but to do that you need an electricity infrastructure that's bigger to do it. And so lots of unanswered questions around hydrogen as well. And I'll finish with some other major uncertainties around what seem to be serious forces happening in the transport world that could have big implications in the energy world. I'll start with superfast charging on the right. Superfast charging is beginning to happen. You can buy a 350 kilowatt charger, sort of, now. Bigger ones are in development. They will give you a fuel station experience. So you'll go somewhere central, you'll plug your vehicle in, you'll charge it fast. Firstly, that starts to imply a new class of large electrical load around the place, and I can imagine they might develop at strong points in networks and so on, so that's okay. But if the market evolves in a way that superfast charging starts to dominate and you don't bother to charge on the street anymore, there's an issue of relative timing here. How much investment will we have made in street charging that then becomes stranded as consumers opt for superfast charging? And then the other imponderable thing from an electricity point of view is what happens if we move to a sharing model for electric vehicles. At that point, they're going to be controlled by fleet owners, and I can imagine their business model will make as much money from playing the electricity market on V2G as it does on supplying transportation services. So that could all be very interesting, but those fleet charging locations are likely to be relatively centralized. They're likely to connect to strong points on the electricity network. So again, domestic, workplace, on-street charging might start to become redundant, and over what time scale. So you've got some really interesting questions as to how consumer pressures on superfast charging and technical development on autonomy could end up driving a kind of rather messy transition between charging electric vehicles on street and charging them in some other way. So I'll conclude with that, but I hope that's some food for thought, and I look forward to the discussion. Thank you.